Welcome back to my channel. Today I'm going to show you how to identify sinks or depression on your digital terrain model. It is important to identify sinks or depression in case you are asked to make a flood hazard map of a potential or existing refugee site. We are working on the same example like in the last tutorial. We are now in the Republic of Congo, Betu. We have a refugee site. Here you see two digital terrain model displayed. The first one is digital terrain model based on FABDEM, clipped on the area of interest, resized to 1 meter resolution and reprojected to UTM. And here you have the same digital terrain model, but after the process of filling the depression. If you do not know how to come to this point, please have a look to my tutorial about watershed analysis. Let's proceed. So first what you need to do is to take the Raster Calculator and to include here the original digital terrain model, this one. You subtract the digital terrain model that has been modified and where the sinks have been deleted. You give a name. I call them depression, for example. You check that the projection is correct and you click OK. You get this one. Now, in those locations where the two digital terrain models are equal, so there is no sinks, the result is 0. I check the information icon, I click here, and here I have the value 0. Check here, for example, I see I have a negative value. It means this area is a sink. Now, how can I display those sinks? I have two methods. The easiest one is just open the properties, go on symbology and click on contours. You see now all the sinks have been displayed, but this is still a raster. So I want to vectorize this raster file, and in order to vectorize that, I have first to create the contour line. I go to raster, extraction, contour. I take this depression raster file, and here I take a very small equidistance. Let's say I take 1 centimeter. So I will have a contour line every centimeter. I run it. It might take some time. Close. Okay, now we see I have the contour line which are actually at the same spot of the depression. Next, I will convert this contour line in shape. So I type on the processing toolbox line to polygons, contours. I run. Now I have converted those contour line in polygons, but you have to be carefully because here there are many polygons. I can show you. If I take away, for example, this polygon, below I have another one, another one, another one. So go back. What I will do now, I just want one polygon, not so many layers of polygon. That's why I will use the command called dissolve. So I type dissolve, and important, keep this joint features separate. I click run. Okay, now I have this one, and you can see I don't have anymore many polygons, but only one. Those polygons, they are not nice looking, so I will smooth the polygon. Okay, now it is a little bit better, but doesn't change really a lot. At this point, I can save this polygon and change the name, make permanent. I call them sinks. Okay, and I have to display it at this point. I click twice. I do it a little bit transparent, 30. I will take away the stroke line. I will do it blue and apply, and I have it. Let's see how it looks like. Okay, now I see the area that are most probably flooded when it rains. If I add my natural streams, I can see more or less where, based on this digital terrain model, where I will have a lot of water, where I will have most probably flooding. This, of course, it is a preliminary study. This map needs to be verified on the spot and eventually adapted to the reality. For the verification, you can make a participatory exercise with the population. You have to observe and to check all the existing drainage and all the existing parameters that you can see on the area. Thank you for following this tutorial.